Okay. Continuing off where we left off, we were coming from Justin Jackson on his Nerd Mullet site and being a webmaster. BBS sysop. I need to set up my own BBS server. Favorite games include Duke Nukem 2, Wolfenstein 3D, Doom, Commander Keen, Raptor, and Epic Pinball. But anyway, we're over here with Tim Bernay. Or Burner, one of the two, in his answering questions because he was linked in one of Justin's posts. I was working in a physics laboratory called CERN. CERN in Geneva, Switzerland. Switzerland is near the middle of Europe. Switzerland, Europe, where all the Nazis hid their gold. At CERN, people study high-energy physics. That is the physics of really, really small particles, particles much smaller than atoms. It turns out that if you want to investigate really, really small things, you need huge machines called accelerators to smash particles together really hard. Then you have huge gadgets about the size of a house which detects what happens and what bits fly off, so you can figure out whether you manage to make any new type of particle. CERN is a big place. A few thousand people work there. Many of them are scientists whose jobs are at universities in different places in the world, and they come to CERN because they need to use the huge accelerators at CERN. We throw things at each other to see if we can make something new by throwing them at each other. This is a very, very man thing to do. We break things to make new things. What made you think of the World Wide Web? Well, I found it frustrating that in those days there was different information on different computers, but you had to log on to different computers to get at it. Also, sometimes you had to learn a different program on each computer, so finding out how many things worked was really difficult. Often it was just easier to go and ask people when they were having coffee. Because people at CERN came from universities all over the world, they brought with them all types of computers, not just Unix, Mac, and PC. There were all kinds of big mainframe computer and medium-sized computers running all sorts of software. I actually wrote some programs to take information from one system, convert it so it could be inserted into another. More than once, and when you're a programmer and you solve one problem and then you solve that one that's very similar, you often think, isn't there a better way? Can't we just fix this problem for good? That became, can't we convert every information system so that it looks like part of some imaginary information system which everyone can read? And that became the World Wide Web. What happens when I click on a link? Actually, it was a grown-up who asked this very reasonable question. When you understand this, then you will understand the difference between the internet and the web. And you'll realize that it is all quite simple. You can skip the bits in small type. No. When you're reading a web page, the computer isn't showing you everything about the link. Behind the underlined or colored bit of text you click on is an invisible thing like HTTP blah blah blah. It's called a URL. This is the name of the web page to which a link goes. The web page you're reading has this one. Behind each link behind you, hidden from you, is the URL of the web page, the one you'd get to if you followed the link. When you click a link, your computer takes this URL. It wants to get a copy of the web page. There are a few different ways of doing this. The one I'm going to tell you about is just used for URLs which start with HTTP. This whole recipe I'm going to tell you, which your computer uses for getting web pages, is called the Hypertext Transfer Protocol. That's what HTTP stands for. There are other protocols, but this is the most common one. If the URL starts with HTTP, then the computer takes the next bit of the URL between the / and the slash. It might be www.w3.org, for example. This is the name of the web server. However, it can't communicate with the web server until it knows its computer number, because the internet actually works with numbers. A computer number is actually called the Internet Protocol address or IP address. It is normally written as 4 numbers with dots like so. So there's 2 stages of this. First, finding out the number of the web server, then asking the web for a copy of the web page. Your computer makes up a packet of information. An internet packet is a message, a bit like a short email or a long text message. The packet starts off with the number of the computer the packet is going to, and then the number of the computer which sent it. And then it has what the packet is about, then whatever it is one computer sending to the other. Now all the other All over the internet, there are special computers whose job it is to keep a list of computer names and numbers. When your computer is set up, it is set up to know the internet number of one of these. Your computer sends the packet off to it, saying it wants to know the number of www.w3.org. A computer which can look up computer names, domain names as they are called, is called the domain name service server in the network preferences. If you really want to know when a DNS server looks up a computer name, it either knows it because it has it in a list or just asks another DNS server which knows more names. How does the packet get there? Simple. Your computer sends it down the internet connection or phone line from your computer, transmits it by radio to a base station, which sends it down some wire. Whatever that wire goes through, eventually it connects to some other computer, maybe one in the cable company or phone company. The internet is a net, really shaped like a real net, like a fishing net, of computers all connected together by various cables. Each computer, when it gets a packet, looks at it and sees what computer number it's being sent to. It then just passes it to the next one in the general direction towards its destination. Pretty simple. Yeah, it's simple. The packet gets passed on until it gets to its destination. Typically, a packet might get passed on by more than 10 computers before it arrives. This way of getting to a packet to its destination is called the Internet Protocol. In this case, the destination was the name server. The name server looks up the number of the computer from its name. Of course, the name server knows the number of your computer because that was in the packet too. So it sends a reply packet to tell the computer the number it needed. Okay, your computer now knows the number of the web server, so it goes back to the URL. Remember the thing which started with HTTP colon? Let's say the URL behind the HTTP is like that bit there. It has used the www.w3.org bit to find the number of the web server, which was a copy of the page. Now it sends off a request to that server, asking it for the web page. It sends the whole URL, and the server sends back a copy. Only problem is that the web page won't fit a packet. Packets can only be around 512 bytes. Bigger now, but about long enough for a text message of 500 characters. Even the request that your computer sends off can be longer than will fit in a packet. So what happens is the computer breaks the messages into parts and sends each part in a packet. I told you this isn't rocket science. It's just like a television series coming in installments. It also puts in each packet a packet number so that the computer can make sure it's got all the packets and got them in the right order. This method of splitting messages up into packets and putting them back together again has a name, which you don't have to remember. It's Transmission Control Protocol, or TCP, so that's what people mean when they talk about TCP/IP. And then UDP just doesn't care. So your computer gets back a bunch of packets with bits of web page in it, puts them in order, displays them on your screen. There are special codes called HTML tags, which tell it when to do things like headings in bold and italics, and of course, links. Yes, every time it finds the HTML tag for a link, it displays the text specifically like blue and underlined and makes a note of the URL of the link page, because at any time you could click on the link and it'll be doing this stuff all over again. This really needs lots of nice diagrams. Yes, it does. Did you invent the internet? No. When I was doing the World Wide Web, most of the bits I needed were already done. Vint Cerf and people he worked with had figured out the internet protocol and the TCP. Paul Petrus and friends had figured out the DNS. People had already used TCP, IP, and DNS to make email and other cool things, so I could email other people who maybe would like to help work on making the World Wide Web. I didn't invent the hypertext link either. The idea of jumping from one document to another had been thought about lots of people, including Vannevar Bush in 1945 and by Ted Nelson, who actually invented the word hypertext. Bush did it before computers really existed. Ted thought of a system but didn't use the internet. Doug Engelbart in the 1960s made a great system, just like World Wide Web expected, that it just ran on one big computer, as the internet hadn't been invented yet. Lots of hypertext systems had been made, which just worked on one computer and didn't link all the way across the world. It's like your local wikis in VimWiki, Obsidian, and so on now. I just had to take the hypertext idea and connect it to TCP and DNS, and ta-da, World Wide Web. No, just like that. No, actually, the inventing, it was easy. The amazing thing which makes it work is that so many people actually made web servers, and that they all work the same way on the internet. They all use HTTP. So the difficult bit was persuading people to join in and getting them to agree to all use the same sort of HTTP and URLs in HTML. I'm still doing that sort of thing. The World Wide Web Consortium is like a club of people and companies who feel the web is important and keeping it working is important. Making it an even better and even more powerful is important. I am the director of W3C, but thousands of people are now working on all kinds of wonderful things. Why do you keep saying everything is simple? Well, because it is, basically. No, honestly. I want you to know that you too can make new programs which create new fun ways of using computers and using the internet. I want you to realize that if you can imagine a computer doing something, you can program a computer to do that. Unbounded opportunity, limited only by your imagination, and a couple of laws of physics. Electricity, namely. Of course, what happens with computers is that you have a basic simple idea and then you have to add things onto it for practical reasons. So real-world computer programs can end up with a lot of stuff in them. If they're good, they are simple inside. What did you do when you were a child? I grew up in the southwest London. I wasn't very good at sports. When I was 11, I went to a school which was between two railway tracks, so I saw lots of trains and started train spotting. I also had a model railway in my bedroom. Some people don't like trains anymore, model trains. It was long, thin layout with a 4-track station in the middle, and on each side pairs of tracks going off into tunnels to actually loop back to each other. I made some electronic gadgets to control the trains. Then I ended up getting more interested in electronics than trains. Later on, when I was in college, I made a computer out of an old television set. I bought the television from a repair shop down the road for about £5, probably $7. My mother and father were both working with very early computers when they met. Later on, my mother taught math in school. They taught me that math is a lot of fun. In England, mathematics is maths. In the USA, math. When I went to Oxford University, I studied physics. I thought that science might be more practical than math. Halfway between math and electronics. In fact, it turned out to be a very special subject all of itself and fascinating for all that. Can you tell me more about your personal life? No, I don't want to, sorry. Yeah. Blah, blah, blah. You got everything. But I am doing a project where we have to get primary sources, which means I have to interview the subject, and I'm doing it on you, so I have to interview you. Sorry, don't have time to talk to everyone individually. Please use web pages. I'm interested in math. What exciting stuff is there we don't do at school? Some kids find solving math problems as fun, the power of having new techniques and imagining new math concepts. If you're one of those and you're wondering what bits of math might be fun to follow up on your own or with friends or friendly adults, here's an attempt to explain some paths which connect together. Some of it is easy, some hard, but honestly, which is which? Yeah. Vectors, let's see, variables, more vectors and variables. So do you think the web has basically been a good idea or a bad one? Some people point out that the web can be used for all the wrong things, for downloading pictures of horrible, gruesome, violent, or obscene things, or ways of making bombs which terrorists could use. Other people say how their lives have been saved because they found out about the disease that they had on the web and figured out how to cure it. I think the main thing to remember is that any really powerful thing can be used for good or evil. Dynamite can be used to build tunnels or make missiles. Engines can be put in ambulances or tanks. Nuclear power can be used for bombs or for electrical power. So what is made of the web is up to us, you, me, and everyone else. Here's my hope. The web is a tool for communicating. With the web, you can find out what other people mean. You can find out where they are coming from. The web can help people understand each other. Think about most of the bad things that have happened between people in your life. Maybe most of them come down to one person not understanding another, even worse. Let's use the web to create neat, new, exciting things. Let's use the web to help people understand each other. This last part I really like, actually, because you find too often on social media, people are slinging and hurling things at each other. Whereas if you go to the right corners of the internet, people that disagree with each other are having civil conversations. And that's a use of the web that is building bridges and getting people to come together and understand one another. And that's what avoids the wars, the riots, and the violence, is the fact that we can sit down together and talk things out rather than resorting to slinging and hurling insults at each other. And in light of recent things, that's what some people tried to do. And because of the hate-filled things going on the internet, they were killed for it. And if we actually use the web for communicating and understanding each other, and not jumping to conclusions, then maybe we could avoid situations like that. Because again, it's just a tool. Where is it? Yeah. It's just a tool, and what it's made of is up to us. And we have to change that. And a lot of these smaller websites seem to do that. So if you're a webmaster, this is a web page. It's very simple, and sometimes we get so hung up in the ease of technology that, like, when we go back down to the nitty-gritty and we actually talk about things that we're passionate about, but we're also willing to sit down and listen and understand each other, then we can make it a good thing rather than just a whole negative experience. But also remember, we've got to go touch grass every so often. If you liked the content, if you enjoyed it, if you think I deserve it, like, comment, subscribe, leave any criticisms you have or what have you. I appreciate it. Feed that algorithm, like I said, and I will see you guys in the next one.